in multilingual natural language processing, and is the perfect place to be in a data science environment and data science institute environment, especially because of the mission of the data science, which is basically to really develop technology to unlock the global data to solve the society's most challenging problems. And we are part of, specifically of the Center for Data, Media and Society, where the vision, and this is created with Kathy McEwen's founder of the Data Science Institute, generating presentations that connect events, opinion, personal accounts, and their impact in the world. And we want to look at that both at processing traditional media, news article, as well as looking at social media and how are the events portrayed in social media and presenting the information in multiple languages. So just to give you some scenarios, so you can see, for example, events that happened in the world, like earthquake in Nepal, Ebola in West Africa, or just the entire financial crisis in 2008. And you have all of this information and events reported in a lot of media, in newspapers, in a lot of languages, social media, Twitter, or discussion forum, people talking about these events. And also, if we want to deploy missions for example, in Nepal, we don't speak the language, but we want to understand how people are actually talking about that in social media, understanding where the special need is. So we are working kind of in this space, trying to develop technologies that are helpful in these scenarios. So what I'm going to do, and I'm actually great that Anthony was before me, he kind of gave a very big overview and broad vision, which our work kind of fits into. I'm going to zoom in two specific projects we are working on. And the common vision is a quote from a journalist who, with this Finnegan from the New Yorker, saying, you fish for facts and instead pull up boatloads of speculation, some of it well-informed, much of it trailing tangled agendas. You end up reporting not so much what happened as what people think or imagine or say they happened. So I'm going to speak specifically about two projects. One is really looking at detecting sentiments and belief towards events, entity, and relations across different genres, news and discussion forums in English, Chinese, Chinese and Spanish. And these I call them high resource languages. And then also another project here at Columbia of identifying sentiment and emotion in social media, but in a low resource scenarios. And I'm going to make the difference when I'm going to discuss about the technologies we are developing for this. So the first project, which is detecting of the sentiment and beliefs, it's part of the DARPA DEFT program, which is Deep Exploration and Filtering of Text. And this is a multi-university project. Columbia, my colleagues Owen Rambo, who is the PI, Kathy McEwen, Julia Hirschberg, and myself. And at George Washington, Mona Diab, University of Washington, Mario Ossendorf. So let me give you kind of the big contribution that our project has, and I'm only going to talk about specific aspects of it. But what we have is that there are people in the real world, and there are events in the real world, what, who, and when. And there is technology right now and that identify, like Anthony mentioned, like entities, event recognition, disambiguation, and let's say knowledge-based linking. So we are not focusing on that. We are focusing on, once we have identified this entity, relation, and events, we really want to know what is a person's opinion or sentiment or belief towards these entities, events, and relations. So for example, here there is a person, Charles in Paris, who might have positive sentiment towards specific events or negative sentiment, like in here, like disliking, and beliefs, and I'm going to come back to this notion of committed belief and uncommitted beliefs. So we want to say, well, he has this sentiment towards specific events, but what is useful is that if you know specific sentiment, for example, about the specific events, you can also infer other sentiments that might have. So for example, in this case, Charles is more likely to support Marine Le Pen. Another part of the project is looking at language. We also want to understand if a person is an influencer, can that person change someone else's mind through dialogue, or if the person is an influencer and is a social media, or is he's basically endorsed by the community. So this is kind of the big area of research we are looking at. And I'm going to talk about two, more or less like sentiment analysis. So in our scenario, you have already, as I mentioned, the entities, Tom and Ida, for example, and you have sentences, very simplified here. Tom likes Ida, so we want to have positive sentiment, and then you have sentences like Tom does not like that Ida is driving the Jeep. And you have the event of driving, and you have the agent being Ida. And you want to say that's negative sentiment, but you also, and then you also have the belief, which is a committed belief, because Ida is driving the car, he's convinced that she's driving the car, so that's a committed belief. So this is a simplifying example just to show what we are after. So basically we're after creating these links between people and events. So why would we care? Like, why you really want to care? So agent's cognitive state, belief and sentiment is part of the reality. So we should, if we are building knowledge bases from text, we want to capture this. I'm a 19-year-old and this 16-year-old likes me. So we want to have the sentiment. Also, these cognitive states, both the sentiment, especially beliefs, affect language production as well, which we can exploit to, for example, we might want to use this information to assess the truth of proposition. So I say John may have violated protocols. So if I'm thinking about the proposition of violating protocols, if I use the hedging word may have violated, this might not be true in the real world. So we want to capture, this is the notion of uncommitted belief. We also want to say who is the author of that belief. So in this case, you have Maria saying John may have violated the protocol. And then making connection to Anthony Joseph think, you can also say Maria thinks John may have violated the protocol. So again, hedging. So you don't know sure if Maria really thinks about what it is. And these cognitive states can be used to find social relation, important people, and so on. So I'm going to talk in this part about the work on sentiment. And we are looking in this project about source-target sentiment. So we want to move beyond just detecting polarity of sentiment at the text level. So there is a lot of work, for example, detecting if a movie review is positive or negative, or this particular tweet is positive or negative. What we want to do in this project is not only to detect at the text level, but we want to identify who is the source of the sentiment and what is the target of the sentiment, as well as the polarity. So the source can be an entity, and in this project we work on several types of entities like person, organization, location, geopolitical entities. The target can be entity, event, or relations, again, with specific types. So I think for events we have 8 types of events we are looking at. And the polarity is positive or negative. This is a new area of research, and the first community-wide, it was actually a pilot evaluation that happened last year in 2016. I'm going to show you some results on that, so it's very new. We look at discussion forum as well as news articles, and we look at English, Chinese, and Spanish. So our approach is to develop language-specific technologies. And we're going to develop systems specifically for English, Chinese, and Spanish in this project. All 3 languages, I can consider them a high resource from the sense we do have technologies, for example, syntactic parsers, or name entity recognizer, or part of speech taggers, or sentiment lexicons. There exist in each of these languages. Of course, more or less, some of them have less coverage, and you're going to see in the results. But I consider that as being a high resource, as well as annotated specific data for the task, also annotated in each language. And that's why we're developing, in this case, technology for language specific. And I'm going to show you in the next part of the talk different type of technology needed when you don't have these high resource languages. So for the English system, because it was a hard problem, we did a simplifying assumption that the source is always the author. And we work a lot with discussion forum, and because the author of the post most of the time is the author, is the source of the sentiment, we consider that as a simplifying assumption. We are working now to move beyond that, but that's kind of the scenario where we are working now, right now. So what we are doing, we want to develop this target-oriented sentiment system. However, this is very challenging because sentences are complex and long, both in discussion forums and in news. And you might have more than 5 potential entities or events or relation expressed in that sentence. So even defining the sentiment towards an entity, you don't know exactly. For example, you might have 5 people mentioned in that sentence, but you don't know the sentiment towards which person is specifically. So what we do in all the languages, we use syntactic parsing to determine the context of the potential target, and we develop features for our scenarios related in this much more smaller context, so we look at close level rather than the entire sentence. So our approach is like supervised machine learning, and for the community, this is again an effort on the entire program of the DARPA Dev program, and Linguistic Data Consortium have spent time annotating some both like in Chinese, English, and Spanish source target sentiment. We are working on 2 conditions. One I called gold entity relation and events, which means that we are using entity relation events annotated by humans, including the co-reference. So this is given, so we don't have that. And then there is also another condition, which is called predicted entity relation events, which means we are using state-of-the-art systems that are able to detect entity relation and events in all the languages. And we are using system from the Rensselaer Polytechnic Institute, Heng Ji's group for English and Chinese, and Illinois Urbana-Champaign for Spanish. So this we call the predicted ERE condition. And I'm going to report results on the gold EREs because that's our task is more sentiment, so we are not, we don't want to confound, but I'm going to mention our results for the predicted ERE as well. So we use linear SVM and random forums, standard classification. So for features, for the English system, you use sentiment lexicon. So the first one is the emotion lexicon from NRC. And they contain both, I think, around 50,000 lexical items that were labeled using crowdsourcing. So they are labeled by humans for sentiment. Bing Liu sentiment lexicon. And this is more from kind of product and movie reviews, and MPQA, which is the classical subjectivity lexicon used in sentiment analysis in general. And I'm not exactly sure the size, but maybe around 7,000 entries for that. We use pre-trained word embeddings weighted for part of speech, and this is from the Billion corpus from the GLOVE dataset from Stanford. We also use a feature type of positive target entity. So for example, if you have an entity which the type is conflict, you're more likely to have a negative. So we want to use this type information for the entities for that. We look at position of possible target in the sentence as well as word embedding for authors and posts. So for example, what we want to capture for the last one is like an author tends to be negative, to have a lot of negative sentiment. We want to capture this in the features. So these are the results for English. Again, this was on the pilot last year, and we are continuing improving the system. These are the results from last year. We are reporting here on the gold EREs, which gold entity relation and events. So what I want to point out is that the genre makes a big difference. So we train discussion forum and test on discussion forum, and we have about 50% F measures. If you train on discussion forum, a test of Newswire drops a lot. Right, so you really need to pay attention to, we have very little data on Newswire annotated for sentiment, so that was a big confounding factor. So then we train on discussion forum and Newswire and test, so we have a bit of improvement. But again, I think your genre makes a difference, even in English. So one of the issue, we have a small amount of training for Newswire in our data sets. And another problem we had when we run the system on predicted EREs, which entity relation and events, the system degraded a lot. So I think here we have 50, and I think it went down to 20% F measure. It was really, really big drop when you rely on automatically predicted entity relation and events. So as Anthony was mentioned, that's still a big issue, even for English, kind of to properly. I think entities right now, it's fairly accurate, but when you go towards events and detecting relation, it degrades. So for Chinese system, we use a very similar setup, but we use Chinese-specific resources. And Anthony gave a perfect example of being extremely important to do proper segmentation for Chinese and to basically to be able to identify meaningful words and phrases, so that's important. And we use a package for text segmentation and part of speech tagging for that. For Chinese-specific feature, we use HowNet Chinese sentiment lexicon. And this is, I think, about 15,000 items in that lexicon for Chinese. And the word embeddings also obtained using the polyglot data set. So they developed in this paper, I think, word embeddings for 100 languages, and they were doing training on Wikipedia. So, and I think it's about 1 million words for that. Chinese results, not surprising, much worse than for English. So we look at this bit of error analysis. The gold data was very noisy. So even people that were Linguistic Data Consortium, they annotated the sentiment, they had problems in annotation. So we had issues in annotations, and also there was very little sentiment in the Chinese data. It was less than 2% of the entire, when you look at entity, it was like sentiment, either positive or negative, so it's very small. Yeah, I'm fairly sure you can. And then the results degrade much more than, so you can imagine going from 18% to like 5% F measure. That's really not good if you look at predicted EREs. So Spanish system, very similar, again, set up for English, modify for Spanish resources. We use word embeddings from the Spanish billion word corpus. Again, I think this ended up being 1 million words. Spanish Dictionary of Affecting Language, and each of these Spanish senti-wordnet, and there were about 2,500 entries for the lexicon. And we use lemmatizer using dictionary-based method. Results, we only had data for discussion forums, so we have approximately 26% F measure on Spanish. So here is the takeaway message: training and testing on same genre helps. And this is across languages. I mean, even in English, it's a big drop. For Chinese and Spanish, we have less annotated, like some errors in the data and less amount of sentiment in both of them. That can be a compounding factor for us. Sentiment result degrade when looking at predicted entity relation and events. So if you use state-of-the-art systems, we are currently participating, actually the evaluation just ended last night or maybe this morning at 6 a.m., which is run by NIST. It's a KB called, what is called cold start population. They give you a bunch of documents, and you really, from scratch, you want to extract entity relation events and the sentiment. So everything is from scratch. We are working now on predicted EREs on an end-to-end system for English and Spanish. And we are only looking at entity-to-entity sentiment. So in November, when the results will be out, if you're interested, we'll let you know how we did on this task. We plan to develop technology to basically detect the source except the author, because right now we are really constrained on that, and especially for Newswire, that's important. We want to incorporate irony, sarcasm, and I'm glad that Anthony mentioned. I'm going to have a few slides about it. I was debating if I should include it, but I think I'm going to talk a bit about the technology we use for that. And also, we want to move beyond just polarity. We also want to understand why. It's important. So if someone expresses a sentiment, we want to understand why the sentiment. So we're working in the area of finding the reason and argumentation mining for that. Just a few slides on irony and sarcasm. And this is really hard. It's a problem for both sentiment and belief. And I'm giving here an example from Twitter. The market index is falling greatly. What a happy Christmas. And you have also part of conversation, so you need to take into account conversation. So if you look at this only user B's comment, one more reason to feel really great about flying. Without the conversation context, you don't know. So user A say play window shades are open so that people can see if there is a fire. So now you can have, well, feeling great about flying, looking at fire, you might want to be able to detect if you look at context. Question is, how can we develop computational models? And I'm going to show you like a work we did like few years ago. So the way that we started even thinking about this problem is how you even get data. Because to develop computational model, you want to see some example, what are sarcastic or ironic messages versus what not. Twitter is a great corpus, which is limitation, but for example, you can use sarcasm hashtag or irony hashtags to collect data. I can't express how much I love shopping on Black Friday. Well, maybe some people do, I don't. So for me, it's very clear. It's a sarcastic message, but that can be also positive. So then you can have sarcasm and as data, and then we also have just really positive examples with happy hashtag or sad hashtags. And we can do that multilingually. So we try to do it with Spanish. So we use sarcasmo, on el trabajo feliz del aburrimiento, which means I'm at work and I'm very, very happy to be bored, right? So you have that in Spanish. So we developed a system, we collected the data, and basically the baseline was just developing a supervised method, extract this data set, lexical features, dictionary based, and look some sarcasm markers, emoticons, punctuation, all caps are used, interjection, and so on, and we run some classification. Well, this was the baseline. But then we wanted to really understand sarcasm. We did some work on trying to model sarcasm factors such as context incongruity. So a lot of time when you are ironic, you do have a positive sentiment, like here, what a happy Christmas, towards a negative event, right? So you have the market index is falling, you have a negative event, and then you have a positive sentiment that's most likely that's a sarcastic message. So what we did, we said, well, let's think about this problem as a type of word sense disambiguation problem, where you have a literal sense of the word and you have a sarcastic sense. So if I have this word, happy Christmas evening, new haircut, ready for New Year, right? So in this case, happy is a positive sentiment. In the previous one, happy is actually a sarcastic. So we did that. This was in the paper. We also presented at the New York Media Lab. And we did it for English. We had collected data both for English and Spanish, but the results I'm going to just report for English. So the key issue here is you need to be addressed how to collect these target words that can have the two senses, literal and sarcastic, and then given an utterance and the target word, how can you detect if it's literal or sarcastic? So what we did, we said, well, we can use crowdsourcing to give sarcastic messages. I'm so happy I'm going back to the emergency room, and ask people to rephrase exactly what you think the author meant when he said that. And they say, they rephrase, I don't like, I have to go, I'm so unhappy, I'm so upset, and so on. So what we did, well, that's a perfect scenario. It's almost like a machine translation set, right? So you have the sarcastic sense, and then you have the literal sense, and you want to figure out, and you do alignment techniques to identify that happy and don't like, and happy and unhappy, and happy and upset are actually opposite meaning pairs. And with this kind of data, you then infer that happy, for example, can be a word that can be a target, a trigger for sarcasm or irony. So we identified the semantically opposite pairs. And then what we did is that we selected example where these words appear in a sarcastic message, where we have the sarcastic hashtag or irony, or in a literal sense where you have labels like enjoy or sad and so on. So we built this for 70. We have a size of training data varies per target. So in some cases we only have 400 examples, and the other one much more. And we develop classification methods using support vector machine in the first case, classical features, and then also a new approach. I'm not going to get into detail, but using word embeddings for that. So here, the baseline is just using the SVM with features. It was about 77%. If we use this new method with word embeddings, we arrive at being about 85% able to detect correctly if a word is used in a sarcastic or in a non-sarcastic sense. So what we are doing now, use conversation context. We have a paper that's going to be presented next month in August at the SIGDIAL. We look at both Twitter and discussion forum, use deep learning, and we really show that if you look at the conversation context, it improves with about 10% F measure. So that's an important point, and we are moving towards looking much more there. And we also look at cross-lingual strategies for sarcasm perception and interpretation. So again, looking at both English and Spanish to see if there is specific linguistic triggers that are in, and actually goes across languages, which I think it's important. We want to combine sarcasm detection with source target sentiment. Unfortunately, on the data that we have labeled, they have like 200 examples literally of sarcasm. So either we get more data or we figure out how to actually use it in the system. Use additional context, especially, for example, the user. So a lot of, especially if you look at social media, some users tend to be sarcastic all over again, and some are not. So really taking into account the user and the history of the user contribution is important. And social roles. We would love to be able to do that. For example, in an organization, you're less likely to be sarcastic towards your boss, more likely to be sarcastic when you talk with your peers. So if we're going to have such data sets, we'll love to look at that. Some challenges, sometimes we need word knowledge. You can't really look at the text or context. So if I say, oh, a shooting in Auckland, that never happens. Well, if you don't know that there is a lot of shooting in Auckland, then it's impossible to be able to detect. So looking at word knowledge will be interesting and hard problem. And different cultural behavior could impact data collection. So even for Spanish, we found that a lot of time, we have much more, less data for people use sarcasmo in Spanish than in English. And I was talking, this is completely anecdotal, but some friends, they were from Argentina, and I say, why? I mean, I just want to, like if I have to put the hashtag, it means I'm failing in my conversational ability. So I'm just not going to use it. So, you know, so the behavior of people and how you collect the data. And for Chinese, we couldn't find anything to be able to actually have any signal about that. It's a completely different. So yeah, that's. Okay, so I hope I have some time to talk about the other project on sentiment and emotions on social media on low resource. This is part of the DARPA LORELEIS program, which is the low resource language for emergency incidents. And here the task is basically to look at analyzing subjective posts of everyday people, which can be short, isolated comments, informal language, so mostly social media. And the task, unlike the previous one that I mentioned, in this case, it is trying to find sentiment at the text level, at the sentence level, more or less, but in low resource languages. So what I mean in this scenario is that we don't have accurate NLP, let's assume we don't have accurate NLP technologies for these languages, such as syntactic parsers. Most importantly, no label data for the target language. So we really don't have label data. So what do we do about that? And let's say minimal translation capabilities as well. So we can translate from one language to the other. The crucial point is no label data in the target language. And this work is Katie McEwen's work and her student and Julia Hirschberg from Columbia. So they are working, and I'm trying to do my best to portray accurately their work. So the approach that is taken in this work is to do cross-lingual sentiment model, and they are working with 16 languages and trying to leverage both parallel and comparable corpora. The key insight is that you might have label data in another language, right? So for example, you have label data in English, and you might leverage the data in English to be able to translate, let's say, in some other language. Or you might have data in multiple languages labeled with sentiment, and this is called multi-source transfer. So single source is only have one language, the other one you have multiple languages that have label data, and you want to use those data sets to be able to translate, to detect sentiment in a language you don't know. Target languages are Indo-European, Turkic, Uralic, Semitic, and Chinese. Two approaches for cross-lingual transfer, and I'm going to just briefly give you the intuition behind that. One is called projection of the source language annotation, and this is using parallel data, and the other one is called direct transfer of source language model. And I'm going to give you just a brief idea what that means. So for the projection to project the annotation from the source language to the target language. So what we assume here, in this case, again, we do not have target language sentiment data. But we do have, let's say, English, right? So you have a large English corpus where you do have, for each sentence in the corpus, the annotation for the sentiment, positive, negative, or neutral. So what you do, you have this label, what they call label training data on the source side, let's say English. You build a model for English, and then another resource you need is a parallel data set. So let's say I want to translate in, let's say, Bulgarian or Romanian. And I don't have data annotated for that, but I do have a parallel data from English to Bulgarian, which is sentence level annotation. So what I do, I train a model on the English side, and then I use that trained model to predict the sentiment on the source side of the parallel data set. So I have a sentence in English and one in Bulgarian. I predict this is positive, and then I put this on the Bulgarian sentence, and now with this parallel corpus, I'm creating my label data set on the target language. I'm building then the model on the target language of Bulgarian, and then I can apply on the test set. So that's single source projection. Now, even better scenario will be, well, you have many languages, you have data. So for example, I can imagine I have data in English, Chinese, and Arabic in similar thing, and I want to translate in Bulgarian. So what I do, I apply this, and you also need to have multi-parallel corpus, right? So I need to have now parallel data from English to Bulgarian, Chinese, Bulgarian, and Arabic to Bulgarian. So I want to do all of these. I train a model in English, Chinese, and Bulgarian, and then for each of that I translate, I predict here, and then I take the majority vote. So for this translation in Bulgarian, I translate one sentence from English to Bulgarian, Chinese to Bulgarian, and whatever, Arabic to Bulgarian. And let's say in two cases, I'm saying positive, and in one is negative. So let's say it's a mistake, then I take majority voting, and that's what I consider to do. And again, I'm labeling the data for that. So that's what's called the projection method. Direct transfer is more tricky. So in this case, you might even do without parallel data. So you want to train a model on the source language and apply directly to the target language. So what I do, for example, let's assume only the single source scenarios. I have a large source of English data. I train a model on English, and I want to apply then on Bulgarian. Well, what's the problem with trying in English apply to Bulgarian? Well, a lot of the feature you use are lexical features, so it's not going to generalize across languages. So what they did is actually they did a method of learning cross-lingual word representations. So then basically you build clusters of words. Let's say this word in English and this word in Bulgarian, very similar, are in the same space of semantic space, and then you use that in the translation. They also do lexicalized code switching. So you create translation dictionaries and translate as many words as you can to the target language. And to translate to basically create this translation dictionary, either you use the hand-built dictionaries, of course these are more accurate, or you use parallel data and do word alignments, and this way you have the translation dictionary. Here is the kind of model, but basically their insight is on the training side. You have a sentence that this is your source, post a photo on to Facebook. So if you use a translation dictionary, then you connect the post with the German word, A with ein, and two with zu, and then all the source language words that you don't have translation for, you leave them unchanged. And they use deep learning methods. They use LSTM, and this was used in order to be able to capture syntactic information, more or less kind of the sequence. And then they also use just average pooling, which basically connect the word representation. And this is for cases where the target language, they don't have the same syntactic structure. because some languages has subject, verb, object, some languages has object, verb, subject. So that might be a mess if you try to keep the same syntactic structure in English. So they use a deep learning model for that. So experimental settings, the languages are Arabic, Bulgarian, Chinese, 16 languages, including this, and these were their test language in the scenario, which I'm trying to remember how to pronounce. Uyghurs? Yeah, exactly. It's a Turkey. It's like in China. We have transfer learning scenarios. Yeah, it is a very interesting. Yeah, and this was their surprise language. So they had, before they give everything in the surprise language was this. With people were like, I can't even pronounce. And this is the problem, exactly. So you have parallel data. So this parallel data was used both for annotation projection, the way that I mentioned, but also was used to detect the automatic dictionary extraction. And I'm going to show you results on that. So there are 3 types of parallel data used, the Bible and Quran. And this was multi-parallel out of domain for all 16 languages. So all 16 languages, you have this parallel data, but it's out of domain. It's a religious text. Then you have Europal for European languages, and this multi-parallel political text available for all the 10 European languages. And basically the in-domain data, which was built particularly for this project, for Linguistic Data Consortium, only the English is the source in this case, but is for the domain. So it's for news, discussion forum, and social media. These were also the scenarios they were testing on. So you have the in-domain data, which is the Linguistic Data Consortium, and this was specifically produced for this program, and only for 7 languages: Chinese, Persian, Hungarian, Arabic, Russian, Spanish, and Uyghurs. Like, by the time I'm going to finish this talk, probably I'm going to know how to pronounce this. So the evaluation data, they used tweets labeled for sentiment for 12 European languages. And also the sentiment, Sentipers, which is the Persian product review data. They use Semeval for Arabic, and for the surprise language, they use a native informant to annotate the data. This is actually the scenario they have to work with. So these are the results. This is for single source projection. So you have English as source, and you want to detect sentiment in all these other languages. And they have 2 baseline. One is all the label everything with no neutral category, no sentiment. And then Senti, the baseline with Senti, what they did, they took the Senti WordNet lexicon and then they use dictionary to just translate the lexicon in all the other languages. So these are the results. You can see that the projection methods beat the baselines in most of the time. What this column show here, what type of parallel data was used. So this was the Bible and the Quran. This was the Parliament, European Parliament, and this is the LDC, which is the in-domain data. You can see that in-domain data from LDC for the language where available is the most important. Like using in-domain data, when you have it, you should use it. It actually beat the type when you use any other languages, but also if you don't have it, the European Parliament for the European languages is also useful. So these are and then this category here, supervised, just to see an upper bound. Then they have, because these languages do have, so they have training data. So basically they train on their own in the specific language data for that. So that's kind of an upper bound, if you will. Now, for the direct transfer, so again, remember this was not used as a projection. The parallel text, the Quran, the European Parliament, and the LDC were only used to build the translation dictionaries. And then what this column shows here, which is a wiki dictionary, so they really use a hand-built dictionary. And one of the main things here is if these dictionaries are of high quality, they helped a lot. So they help much more than the automatic dictionary built from the parallel data, but not so much in other languages. So they help for Chinese, German, and Slovak, because they were looking some error analysis for Chinese, and they say this is high quality. All the other languages, there seems to be very noisy. So high quality dictionary is important if we can have it. But then if you develop the dictionary from the data, again, LDC is. Now, what are the main takeaways from this work? In-domain data, again, this is also we saw in the previous project, is important, enables increasing performance for most of the languages. If you have it, use it. When you compare projection methods versus direct transfer method, for which languages do you want to use? They actually vary by the type of language. So projection works better for non-Indo-European languages, Arabic, Hungarian, and this language. And then the effect of code switching is basically using translation dictionaries is really important for the direct transfer methods. And the single source versus multi-source, I didn't show the results here, but all the results with using multi-source annotation models that was more, improved the performance as well. So just to conclude, for the multilingual NLP, if we develop technologies for that, we really need to look into see if is it a high resource language versus a low resource languages. The technology you develop is completely different. And I show in the first project, we really assume it's high resource. In the low resource languages, you need to figure out something, how to leverage annotated data from high resource languages to be used for low resource. Techniques might be different based on the language family as well. So you really need to pay attention for that. So I didn't show it here, but it's, even if you use the projection or the direct transfer, if you use a source, a language that is in a family similar with the target language, you get better results than if you use a language which is not from that same family. So looking at that is important. We really need to address morphology-rich languages. That's a really big problem. And there is some work at Columbia. My colleague Owen Rambone and his students develop unsupervised methods for morphology analysis. They had the best paper award at Calling last year. I'm not having time to talk about that. But also, especially for low resource scenarios, really having high quality bilingual dictionaries or multilingual dictionaries is really, really important. And this will help a lot, especially for the direct transferred approaches. So I just want to thank you for this. And multilingual NLP at Columbia, more or less all faculty working on NLP are involved in working on some aspects of multilingual processing. So Katie, Mike, Collins, Julia Hirschberg, Owen. And the students are too many to put on this slide, so I'm just showing the students and researchers that were involved in the two projects that I presented.